Okay, give me a second. Let me. Share the presentation. Can you see my presentation?
Yeah, we can see it.
Perfect. Okay, so what I'm going to present to you today, this was a production line improvement. This one was specifically on printers. The reason that I had chosen this one in particular was because of the fact that this was just one of many projects that we had when we were going down the path of inventory reduction and productivity improvement. This one kind of fell in the middle, and I'll get to that in just a little bit. But this is the agenda that we're going to go through: the introduction, what the situation was, or what our problem statement was, the idea that someone else came up with. It wasn't actually my idea. Then the team selection, the plan, the solution, the test, rework and redesign, because what you'll see when I go through this is that when we got to the solution and we were testing it, putting it in place, it didn't work exactly as we thought. And then finally, the results and follow-up. Okay, so as Mark has already said, he and I worked together for a company called WMS Gaming. During the time of this project, the company was implementing continuous improvement methodologies and activities with the desired effect to reduce costs and increase profitability, of course. This was one of many continuous improvement projects, as I said, designed to improve production throughput and reduce inventory costs. And again, it was chosen because there was things that happened prior to this and after this. So this one was one that was right in the middle, that basically said one of the improvements that we did, it was good, but it wasn't great, and we really had to work on getting a better result once we had the initial solutions that we had in place. Okay, so this was the situation. An inventory analysis highlighted that we had a large number of ticket printers on hand. Ticket printers are the things that go in the game. Anyone who's ever been to a casino, that when you cash out, it gives you a ticket. Those are the types of devices that we're talking about. The problem is that we had a ton of these things on hand, and the only difference between each printer was the firmware itself, right? That on the firmware, it had software very specific to whatever that casino was, whatever that jurisdiction was. Okay, so the first thing we did, and this was the project before this, is that we had worked with our suppliers and we were able to return about $7 million worth of printers. Okay, this was early on in the project when we started out with $132 million of inventory and $350,000 or $350 million of sales. That was a problem. So we started looking at kind of low-hanging fruit. This was one of them. Let me see. So we're able to do that. We're able to do the programming ourselves because we already had everything in place to do it. And this was during the time that casinos were more transitioning from having the coins that you put into the games to putting dollar bills into the games and getting a ticket back. So you could use those tickets on any other machine. But this process, in order to do it, it required 3 additional people, and we had errors of about 5 to 7%. Either they didn't program correctly, or they programmed correctly and the wrong one got put into the wrong unit. Okay, so the total time to program the EEPROM and label it and insert it into the device was a little bit over 10 minutes, with the line cycle time being about 6 minutes with the 3 additional the 3 additional people. What this means is that we couldn't take that exact process and just put it in line and have it work. So we had to have an offline area just to do this, and that's why we had all these people, and the moving it back and forth. Anytime that you're moving material after you program it or after you do something to it, there's always a chance for error. So a production supervisor had this idea of, hey, so maybe we can change the way that we do this because we already have all the firmware, right? And we already had it online. And he was thinking that maybe there's a more automated way. So he was able to find where we stored them and kind of what that key was between the bill of materials and the units that were being produced that we were able to capture on a traveler. All right, and so we did a review, and if we could eliminate the seek time is going to the file, finding the exact program, downloading it, and then having it ready, and then actually doing the programming. So if we could reduce that amount of time, we could get that down to probably about 6 minutes. Okay. So working with the production supervisor, remember his name, Arturo Hernandez. We recruited a team of members from engineering, manufacturing engineering, the EEPROM room, production support, production materials, sales, and maintenance. So this was the entire team that needed to be involved, because it wasn't just, I was going to fix this one problem. We have to make sure that from the sales and from an aftermarket point of view, we can support that as well. Right, the maintenance team to set up the lines, the production support because they had additional work to do, the manufacturing engineers to lay out these new areas, and then engineering, of course, to make sure that we didn't have any changes to our bills of materials that they would need to address. Right, doing this project, one of the things I really like to do is have transparency. So some of these people were in there just so they knew what was going on. They didn't necessarily have work to do, but always getting their input was a really good idea. So the plan. So again, looking for upstream and downstream issues. We want to make sure that we're not having any adverse effect on either the product coming in, or when we're doing the work, all of a sudden there's some other problem with some other department. So we wanted to make sure that worked. We needed to identify how to leverage the link from the firmware. We needed to develop the station for adding that to the production line instead of having it as an offline activity. And then document the solution process, complete training for the affected personnel. And then, of course, last one is test it, make sure it works. Okay, the most important part of this entire thing is the training part. Right, because if you do all this stuff and you don't really follow through with the training and documentation, it'll work for about a week or two, and then people will start ad-libbing and they'll start doing kind of what they think they should do as opposed to what you really wanted them to do. So really having the documentation and training was a really key step. Okay, so we did the review from upstream, downstream. There was no negative implications found. There was no additional work needed by engineering, as the firmware was already part of the configuration process. So basically, when we took an order from a customer, the customer would say, here's all the things that I wanted, and then we plugged that into Oracle. Oracle had a configurator, and the configurator then took all of those selections that the customer made and turned it into our bills of materials. Right? Each bill of material was unique per customer. An additional line station on one production line was set up. So we could have that one station that was just doing that, just programming those things and having those ready. We already had a fixture in place, so we didn't have to do anything with that other than move it from the place that we were doing it into this new place. And of course, then we needed IT to help write a link for the software. Is that when the firmware, I can't see. Oh, that's better. When the firmware programming was complete, use that same link to automatically print the label for the firmware, because on top of the EEPROM, then you have to make sure that you're labeling it, so when the customer gets it, they can see that you have the right thing in there. Hold on. Okay. So the process was first completed offline. In other words, we set up the station. It wasn't really on the production line, but we set up a station to do it, so we could really look at it and look at the timing and to see how it would work. The solution itself worked as designed. Devices were put into units for testing, and each one was programmed as expected, without issue, without error, right? Because we were able to do them basically one at a time. We had to buy a barcode scanner, which cost about 25 bucks, and add it to the station tools. And based on doing all that, it was reduced down to the time that we really needed to do it. And again, last thing is training was added to the station, which consisted of inserting the blank EEPROM, scanning the barcode on the traveler, and attaching the label. So that was one of the things that we came up with, was on the traveler itself, we created a barcode that once you scanned it, it would automatically go and find the specific software that we needed based on what was scanned from the barcode. And then it would automatically start programming this device. As soon as it was done, the label printed, and they just peel it off and attach it, and they were done. So this sounded pretty good, and we were pretty encouraged by this. And so we had everything in place, and everything looked really good. But then the question someone asked after we did all this work was, the person at the station has a lot of idle time, because when they're waiting for their programming, which is the majority of the time, they're just kind of sitting there, and they weren't really doing anything. They were just waiting. And so the question was asked, can we put this on the station itself, and then have that incorporated into the line, as opposed to having it as a separate station? So basically what we did is we rebalanced the line, and for the one station that they installed the printers on, we moved a little bit of work around to give them the time up front to do the startup of the work. And then once they started programming, they went back to their task and did all their other assembly work, came back to this at the very end, took the label, put it on the EEPROM, put it in the printer, installed that. So we rebalanced all that out, and then again we tested it, wrote new instructions, and we basically made sure that we had everything set, and then we retested again. That was very successful. So the previous station that was set up was eliminated, and the line was rebalanced. The existing station was modified for the additional task, and the operators were retrained, as I said. Programming label time achieved the anticipated results. Timing for the station was able to achieve the production cycle in less than a day, because it was a really short learning curve. I mean, they had to do basically 3 things, but we basically added a little automation there to make it really easy for the operator to do it. Results. Okay, so those 3 additional people that we were using, we were able to remove them completely from the assembly process. So that saved the company about $210,000 in just labor costs itself. Realigned the line assembly process that allowed programming and assembly into the machine to be completed at the production cycle time, and we reduced the errors from 5 to 7% to 0, because when we did it, we did them one at a time, and it was really we made it so it was extremely difficult to actually make a mistake, as opposed to what we were doing before, where they would do a bunch of them and then you just had to grab one and put the right one in. And then of course you have to stop and you have to read, you have to make sure you got the right one, you have to look it up. We kind of eliminated all that by doing one at a time, so it couldn't possibly be wrong. Last thing we did is after we put all this in place on one production line, we did the follow-up. Right, and we checked with the testers, we checked with the quality people, to basically keep a log on this stuff and start checking this to make sure that there were no errors, that everything was doing exactly what we had anticipated. When we reviewed it with the operator, basically they said this: so you rebalanced the line, you gave us this really small amount of additional work. So for them, it was almost no impact other than no errors. So they were actually really pleased with this because it made their job a lot easier. So, and then once we did this, and once we did all the follow-up, then we took this exact same station and we duplicated it across the 8 different production lines that we had. and put the exact same thing in place because every game took one of these. So we saw that same effect on every single production line. And then this led to other other projects like the Supercore and other things that we had done that we could probably talk about on another day. Questions?
All right, let me ask one question first. Is everybody understand what Bill was talking about generally, or are you a little confused? You can be a little confused, it's all right. And if you're a little confused, ask for a question of clarification. So do we have any of those? No one ever wants to raise their hand, Bill, because it exposes that they don't understand something. But one question I had was, auto companies build complicated things all the time, right? They sequence their production. They have, tomorrow we're going to build, 100, 200 cars on the line during the first shift. And, the cars come, they have black interiors, beige interiors, gray interiors, and they have all the seats sequenced and the steering wheels and all that stuff, interior trim sequenced, so that the next steering wheel you pick is the color of that interior. And they've got this all planned out. And I know you did some of that kind of stuff, but you didn't do that for this. You didn't program them ahead of time. You figured, let's program them during the actual production process, right?
Correct.
Okay. And when you program it during the production process, to eliminate the people, you used a technique called, you did the work parallel, simultaneously, right?
Yes.
So
exactly.
You get something started, it's going to take 6 minutes, let it do that while I'm doing the rest of my job. It's like when you're cooking a meal, right? Some things take longer than others. So you start something, and while it's cooking, it's going to take 12 minutes or 10 minutes or a half hour, depending on what it is. You're making the salad. Is that kind of what you did?
That's exactly what we did.
Okay.
And again, these things that we came up with this solution that we're putting in line, it wasn't my solution. This was the team solution, because they looked at it and they said, so this looks really good, but we think we can probably do something a little bit better based on what we've done here. Why can't we do this instead of this? And then we looked into it and said, well, gee, you're right.
All right. Did you have operators on the team as well? Line people?
Yes.
How valuable was that?
Oh, incredibly, because these were the people that were actually doing the work. And so these were the people that were doing that station, that they were programming or they were installing these printers, right? And so having them on the team, they were giving us really the firsthand knowledge of what would work.
Yeah, like, hey guys, that's a great idea, but it's we can't do it because ABC, or wow, we can do that. That will actually make my life easier.
Right.
And then lastly, I was thinking this idea of what they call idiot proofing, right? If you can make a mistake, people will make a mistake. If you allow the possibility to make a mistake. So a lot of times in manufacturing, they'll create, like, if you're going to have to plug two things together, so you can only plug it together the right way. And it's a design or an engineering technique of the part, or it could be an engineering technique of the assembly line. So you kind of like did that, what the Japanese call poke-yoke there, or
right.
Idiot proofing. Expound on how important that is in a job, because people can make mistakes.
Oh yeah, I mean, so the people who are working on the production line, we're these things called humans, and we do make mistakes. It's inevitable, and it's going to happen. If we can put something in place that makes it harder to make a mistake, that's the ideal situation. When we design for manufacturing, a lot of people like to say, well, you have to design it because these manufacturing people, they're really not that smart. Not the case. They're extremely smart. But what they're really focused on is getting production done, right? And so anything that's going to delay them, anytime that they have to stop and think or stop and do something else leading up to this, that's taking away from their productivity. So if we can basically remove those obstacles and make
Oh, did you freeze? I don't know what touching your computer does to that, but not much usually. His internet, my internet, I don't know.